Last time we learned how to use functions and what they are in theory. And we also learned a few operations we can calculate with them. But now we're ready to talk about composite functions, which is when you apply one function after another function. So let's start with an example. Okay. So our example is fx equals 2x plus 2x minus 3, gx equals x plus 1. Bear in mind, we're now using this as gx, but we've only seen fx. But it's the same thing, it just dictates a different function, and we're labeling the function with a different letter. It's still a function and works in the exact same way. We could use any letter to dictate this. We just use f as a convention for if you only have one function. And now it would say find f(g(x) potential. Now f(g(x) is a composite function. And it means apply gx then fx. So basically what we're doing is we're applying gx, so we get an input and we apply it to the process, and then we get gx out, and then we apply that to fx, and then we get fgx, like that. So what we can actually do to figure this out is we can imagine gx being an input into fx. And we can work from x. So if we find gx now, so gx is equal to x plus 1. We know that, so we can substitute that in. Get x plus 1, like so. But we already know how to do fx plus 1. We just replaced every instance in x with x plus 1. So we get 2x plus 1 minus 3. And we can simplify this, and we get 2x plus 2 minus 3, which is minus 1. We get 2x minus 1 as fgx. We just need to think of that gx as an input into f. Now let's try it the other way around. This will actually give us a different answer, gfx. So first we imagine these brackets, and now we do fx first before gx. So fx is 2x minus 3. And we can put it into g of x. So instead of x plus 1, we'll have 2x minus 3 plus 1. And that'll equal 2x minus 2. Like so. So we know that fgx equals 2x minus 1 and gfx equals 2x minus 2. We can actually combine more of these functions together. We can do fgfx, and that equals, well, we just use a similar approach. So we put fx in brackets. Well, fx is just this, 2x minus 3. And we know how to work with g 2x minus 3. We figured it out here actually. That equals 2x minus 2. So we can put that in f. And now we can just substitute this into here, and we'll get 2x minus 2 minus 3. And that will equal, that's 4x minus 4 minus 3, which is 4x minus 7. And that's how you do composite functions. Now, how about inverse functions? Well, there's actually a bit of theory to this before we start. So remember, you have if we remember this process of, let's get the doubler back like this. So we have our input, our process, our output. So we're putting x in and we're getting 2x out. The inverse is just the opposite way. So we get an input here and we get the output here. And it does the opposite thing. So if you put x in here, you get x over 2, because it's not doubling, it's halving. It's doing the inverse function. Now, the process to actually finding the inverse function involves a few steps. So it involves 4 steps. First off, you need to replace fx with y. And then you need to switch x and y. And then you need to make y the subject. And 4, you need to turn the y's into f minus 1x. But just make sure that it is f. If it's g, for example, this will have to be g and g minus 1x. Now, this might seem a little bit complicated, but many of these steps are actually quite trivial. It's the third step that's the difficult part. So let's do an example. That's number 2. Right, so let's get fx equals x plus 8 over 3. And it'll say find the inverse function, f minus 1x. Okay, so let's start with step 1. So we want to convert all the fx's into y, or the one fx. So let's do that. Let's convert it into y. Like that. We just turn the fx into the y. Now step 2 tells us to switch x and y around. Okay, so we just switch places. Remember, if there's more than one x, you'd have to have more than one y. When you switch it, you have to switch it with all the x's. And now we want to make y the subject. Now this can be tricky. In this case, it's not too bad. We can multiply by 3 from both sides, giving us 3x equals y plus 8. And now to make the y the subject, we just subtract 8 from both sides. We get 3x minus 8 equals y. If we bring this up here, we get y equals 3x minus 8. And that is step 3. So now we need to just do step 4, which is to convert y into f minus 1x. And that is the inverse function. Like so. You can also check this if you have time, and you can find the inverse of the inverse function. And that will give you the original function back. So, because the inverse of the inverse goes back to the original. So you can also do that if you have time. Now, I have a few exercises you can do. So exercise 1 will be a composite function. So find fg x gfx and ffx of gx equals x squared, fx equals x minus 3. Like that. Okay, and then exercise 2 will be an inverse question. So we have g of x equals 4 over x plus 3. Find the inverse. Okay, have good luck with those.